Hello everyone, and welcome to our presentation. My name is Stephanie Toddy. I'm a marketing manager here at ExamSoft Worldwide. Our hosts for today's webinar, Psychometrics 101, are Dr. Jim Wallach and Dr. Sonia Sadivi, both of the Testing and Evaluation Services Center at University of Wisconsin-Madison. Dr. Wallach is director at the center where he oversees all of the center's initiatives. His research specialties are in test validity, and he has developed a number of models that have become standard for use in the psychometrics field. Dr. Sadivi, who you may recognize from her Question Writing 101 webinar in January, is assistant scientist at the center where she supports Dr. Wallach's initiatives. Her research interests as well are in test design and reliability. Together, they have recently launched a somewhat groundbreaking system of administering placement exams throughout the UW system, for which they utilize ExamSoft as a computer-based testing platform and psychometric evaluation tool. Just a couple of quick tips. If you have specific questions, we encourage everyone to type them through the chat feature of this webinar at any time. You can see the little red arrow down there at the bottom of your screen where you would click. To pose a question to the presenter, click on that questions feature, which should be on the right-hand side of your screen right now, and type in the box provided. All questions will be addressed at the conclusion of the webinar. Also, as a heads up, all attendees will receive an email tomorrow with a link to the recorded webinar as well as a copy of the presentation itself. We would also love feedback on our webinar series and encourage everyone to fill out a quick survey that will pop up for you at the conclusion of today's presentation. As a quick reminder as well, we have another highly anticipated webinar next Wednesday, March 6th, entitled Using Curriculum Mapping to Your Advantage, Strategies for Better Assessment, hosted by Dr. James Souza, Assistant Dean of Assessment at St. John Fisher College, Wegman School of Pharmacy, and also Mr. Patrick Chad, Acting Associate Director, University of Medicine and Dentistry of New Jersey, School of Osteopathic Medicine. Full details on the registration page can be found at learn.examsoft.com/webinar. With that, I'm going to turn the presentation over to Dr. Wallach and Dr. Sadivi. Thank you so much for attending, and please enjoy the webinar.
Hello, thank you everyone for joining us today. Today, Jim and I are going to talk about Psychometrics 101 and how you can use some of the reports that ExamSoft provides in SoftScore to help improve some of your test items. So I'm going to start off by talking a little bit about reliability and validity, and then I'm going to pass it over to Jim, and he's going to talk about item analysis and how you can use item-level information to guide item revision. So test reliability really refers to the consistency of scores that students would receive if they were given alternate forms of the same test. Or simply put, it's measurement repeatability. So theoretically, if I have a group of students and I give them a test, record their scores on the test, and then somehow had the ability to erase their memory of having taken that test, I could give them the test again, record those scores, erase their memories again, and do this over and over. And the consistency in their individual scores essentially is test reliability. These scores, however, are not going to be 100% consistent from one time period to the next, because there might be differences in content or the item quality across different forms of a test. There could be some environmental variables that factor into the testing process, and there can be some student error involved. Every test or every measure that we use has some level of error associated with it. And reliability really provides us a measure to the extent of how much error our test has. And some sources of measurement error may include some examinee-specific factors. Maybe our students aren't very motivated or they're not concentrating while they're taking the test. Maybe we have a really long test and they're getting fatigued. They could be careless when they're marking their answers. They could be guessing and getting the item correct. There's also some test-specific factors that could cause error in your measurements. Perhaps there's something about the specific set of questions that you're asking. Maybe you have ambiguous or some tricky questions in there. Or maybe you have directions that students aren't really understanding. And then finally, we have some form scoring guidelines with essay-type tests. Maybe we have a carelessness. We've marked the incorrect key or the incorrect option as the correct one. And then maybe we have counting or computational errors when we're adding up test scores. All of these are various sources of error that might be involved in the testing process. And these are important because this error is random. And so we don't know how it is going to affect the student's test score. It may actually overpredict and give the student a higher score than they should have gotten, or it could underpredict and give them a lower score. In an unreliable test, then the student's scores consist largely of error. And if we have a highly unreliable test, then giving that test and the scores that a student receives in it is really no advantage over just randomly assigning scores to the student. Reliability is also extremely important because it's a precursor to test validity. If we can't assign test scores reliably, then we cannot assume that we are actually accurately measuring what it is we want to measure, and we'll talk more about that here later. So the relationship between test scores and error can be described using what we call classical test theory. And here we assume that every individual has one true score on a test or measure, and this true score is unobserved. So I can't look at somebody and know their skill level in algebra, but I could give them an algebra test to measure and get an approximation of their skill level. And this would be their observed score. And the observed score then is made up of a person's true ability, or what their true score should be on the test, plus the measurement error associated with the actual test or the measure that you chose to administer. So the difference in somebody's true score, their true ability on a test, and the observed score, the one that you actually will record or you'll see on your test, is due to an inaccuracy in measurement. So if measurement error is high on your test, then the difference between somebody's true ability and their observed score is they're going to be pretty far away from each other. There's going to be a big difference there. And this classical model assumes that a person's true score or their true ability level does not change, even if we were to give a test over and over. However, the observed score does change, and this is due to that error component. And this is what we're interested in. How much error is associated with our measure? And you can think of it as error as being quote-unquote badness of measurement, and reliability being goodness of measurement. So reliability really is the correlation between somebody's true ability and the score that they get on your test. So as somebody's true ability increases, we would also want them to score higher on the tests that we're giving. And our measures of internal consistency can give us an estimate to the extent to which the different items on our test are actually measuring the same trait. Do the items hang together, and are they measuring the same thing? And the faculty report that ExamSoft provides gives a measure called KR20, which is a measure of internal consistency. It gives us a measure of how reliable our exam is. This is the top part of the ExamSoft faculty report, and you'll see some information is given on the overall exam performance. On this particular test, the average score was a 62%. The low score was an 11%. And the high score, there's actually at least one person that got all of the items correct on it. It was 100%. It also gives a breakdown of how many exam takers are scoring in certain percentage levels. But down at the bottom here, now in the red rectangle, you'll see that this is where we report reliability. And so there's a bar that measures goes from poor to good, and you want to make sure that your reliability of your test is falling somewhere in the yellow to the green range. So the reliability level of this test, as you'll see, is a 0.92, which falls under good reliability. And ultimately, this is what everybody wants to know. They want to know how reliable should my test be. So some guidelines that we offer are that for high-stakes, standardized tests, you want your reliability levels to be at least 0.9. For standardized tests that are considered low stakes and subscores on high-stakes standardized tests, we want reliabilities to be at least 0.8. And for classroom tests, we want our tests to have reliability of 0.7 or higher. And generally what we're looking at is we really want to make sure if we're using our tests for any type of decision making, we want the reliability to be at least 0.5 or higher. Anything under 0.5 is not going to be acceptable for decision making because you actually have more error in your measurement or in your test than actual measurement. So let's say you give a test and you get your report back and the reliability is not as high as you would like it to be. What are some of the things that you could do? Well, first we want to make sure that we're using well-written items that have good item statistics. And Jim will cover what we mean when we say that they have good item statistics. We can also increase the number of quality test items. I put quality test items in here because we can't just throw any old test item in there. We want to make sure that it's measuring what we actually want to be measuring. And if we do increase the number of test items, this might be how our reliability changes. So this looks at how reliability increases as we increase the number of test items. And what you will notice here is that the increase in reliability will kind of start to level off eventually. There's a ceiling effect where adding more items is not going to improve your reliability much more. So here, somewhere around 25 items, 27 items, we start to see it really level off. And then finally, if we give it multiple midterms or multiple exams, that's going to help improve the reliability of final grade in the class. So this graph here shows what the reliability of any one exam is if you increase the number of exams with that same level of reliability, what it does to the reliability of a final grade. So for example, if I have one test that has reliability of 0.7, then the reliability of my final grade is also going to be about 0.7. If I add a second test there with the same level of reliability, that reliability of the final exam then, or final grade, is going to go up to about 0.81. 3 exams, it's going to go up to about 0.86. And 4 exams, it's going to go up to about 0.9. So that's another way that you can increase reliability of final grades in your courses. So validity then refers to the extent to which the inferences that we make from a test are justified or accurate. What you'll commonly hear is, are the test scores measuring what they're supposed to measure? So let's think of a game of darts here. If I get up there and I throw my 3 darts and I clump them all together, but I just happen to hit the 1, that's reliability. Being able to consistently throw 3 darts and clump them all in the same spot on the dartboard. Validity then is hitting the bullseye, hitting your intended target, measuring what it is that you want to measure. So what if I get up there and I throw darts and I end up hitting these 4 spots? I'm kind of all over the board there. They average out to be close to the middle, close to my intended target. However, there's so much variability in where I threw these actual darts that I can't be confident in my overall accuracy. And the same is true for test scores. If test scores are bouncing all over the place, then I can't be confident that they're ever going to actually measure what I want them to measure. So validity is the psychometric property about which we are most concerned. Informally assessing validity for a specific test is pretty time-consuming and it's pretty involved. But the first step in this is often reliability analysis. And that's because, like we've said, reliability is a necessary but not a sufficient condition for validity. So I can throw my darts consistently and clump them all together, but be nowhere near hitting the target. But in order to hit the target over and over, I need to have some consistency there. So I have to have that reliability component first. Because large-scale validation studies are so time-consuming, we usually reserve them for high-stakes testing situations and not for classroom exams. But for classroom purposes, we consider that a test is valid if it's written to comprehensively measure the major objectives or part of a course or part of a course. So we need to know what our course objectives are and whether our items are actually measuring these objectives satisfactorily. And in SoftTeach, this is what you can use item categories for. Each individual item, you can assign a category to it, and you could use this to assign your test objectives, because then you could run an analysis later based solely on those individual objectives, which we'll see here momentarily. Okay, so some of you may have already heard this before, but how we do this is with a test blueprint. And the blueprint is going to identify our course objectives and the skills that we want to measure. It will include each of these objectives and its relative weight on the test. We want our objectives to represent as much as possible it is that you want to measure on your test. I think we want them to be specific enough that we can write items that measure that actual skill or objective, but general enough that we can write more than one item. So this is a sample physics blueprint. So you notice here we have each of the objectives listed and what percentage of the test should fall under each of those categories. We want to write our test blueprint before we actually begin writing test items. Otherwise, we find that we end up writing a bunch of items simply because they were easy to write, but they might not necessarily actually measure all of the different contents that we want them to. The test blueprint is also helpful if you want to develop different forms. If you want to use Form 1, Form 2, if you're teaching large classes, perhaps. You do want to be careful when doing this, though, because the tests are not going to necessarily be equally difficult, but you will know then that they do cover the same content, the same proportion, as long as they're both following the same blueprint. And along with this blueprint, we can also build in some measure of item difficulty. What percentage of items do you want to be categorized as easy, medium, or hard items? Once you've administered a test and you are collecting data, in the faculty report, they also provide some learning outcomes. And this basically breaks down questions based on what your categories are, or in this case, your learning objectives. It tells you how many questions are provided under each category, and on average, what the performance is of these items. It can help you make sure that you're testing or having enough questions come from each of your categories, and then you can see how well those items tend to be performing. So reliability and validity really are the two main concerns that we have in test design. But ultimately, the individual items are the building blocks of the test. So the first step in actually creating a reliable or valid test is to make sure that you have good items. If a test is unreliable or lacks validity evidence, then your first step is to actually investigate the individual items. And Jim is going to talk with you about how you can do this.
Excellent. Thank you, Sonia. There really is no replacement for high-quality items. None of the stuff that I'm going to talk about can be used to overcome the fact that if you aren't following the best practices in writing items, you're not going to be able to develop tests that are reliable and valid. And so, with that in mind, I hope that you had an opportunity to attend Sonia's workshop from our webinar from a couple of weeks ago, or maybe can access it on the ExamSoft archive. So you'll hear me say this a couple times. and I mentioned that Sonia probably said this a couple weeks ago as well, writing items is really hard. I think a lot of people think that it's pretty easy, but writing really good multiple choice items is very difficult. We often find that it takes us much longer, especially if we're trying to do it well. We develop a blueprint, and we know that some categories are going to lend themselves pretty well to items. Other categories maybe not as much, and so writing items that fully cover what we want to do and do it well is difficult. We spend a lot of time on it. But unfortunately, in my experience, people really don't spend a whole lot of time on the back end analyzing how well those items work and taking a look at the data after the exam's been administered to see whether or not the items functioned as we sort of expected them to. The good news, of course, is that when you administer a test, especially a multiple choice test, you have a lot of really rich data that you can use to study those items and see if they actually did behave as you might have expected them to. The process of studying these items is what's referred to as item analysis. So, item analysis provides a breakdown of how different types of items perform in various aspects of each item, and this is something you can do for any type of item, but it's especially common and especially useful with multiple choice items, and that's the context in which we'll talk about it today. All right, so item analysis can help you answer the following questions. How hard is an item? How well does the performance on this item predict overall achievement level? Are students finding distractors the wrong answers? Are they finding those to be attractive? Is the item confusing? Does an item maybe have more than one answer that's actually correct? Or does it have only one right answer, as I'm sure was intended? It can help you figure out what types of students this item maybe is ideally suited for. It can help you figure out if the timing is appropriate, or maybe students at the end of the exam are hurrying and not getting an opportunity to get to those items. So there are a lot of different ways that item analysis can be really helpful and can provide very good feedback to you about what's going on inside your test. There are two statistics really that we attend to when we look at an item analysis, or at least that we attend to more than the others. The first of these is called the item difficulty. The item difficulty is simply the proportion of students who answer an item correctly. Because it is a proportion, its values range from 0 to 1. Within the context of a multiple choice item, usually you're dealing with a 4 or 5 alternative multiple choice item. And so if it's a 4-choice item, we know students can guess that item correctly about 25% of the time. So once the difficulty starts to get down in the vicinity of the guessing probability, it's pretty hard. So usually we say items that are have difficulties less than about 0.35 for if we're talking about a 4 or 5 alternative item, maybe less than about 0.4 or 0.45 for a 3 alternative item. Those are pretty hard. On the other hand, items that have difficulties up in the high 80s or 90s are pretty easy. It means that most of the students in the class are getting those items right. It's okay to have some easy items. It's okay to have some hard items. But if you have too many of these items, then you're probably going to have a test that's not particularly reliable. If everybody is getting the item, if you have a test with a bunch of really easy items and everybody's getting high scores, then you're really not in a position to use the total test score to help distinguish which are the high achievers and which are the low achievers. And that's what reliability is really all about. It's about sort of ordering the examinees and being able to consistently order them in the same sort of way. So it is okay to have items that are hard, to have some items that are easy, but the bulk of your items should probably be of more moderate difficulty if you're really interested in having a test that's highly reliable. So the difficulty I mentioned is the proportion of students who answer the item correct. We also like to attend to the proportion of people who are selecting each of the wrong choices. We call those the distractor difficulties, so the percentage who pick each of the different wrong choices on a multiple choice item. The second statistic that we like to attend to when we do an item analysis is item discrimination. There are a couple of different measures of item discrimination. The one that I'm going to talk about first is the point by serial correlation, which we abbreviate RPBI. And this is simply the correlation between a student's score on the item, that is, do they get it right or do they get it wrong, and their total score on the test. Or if we're talking about one of the wrong choices, it's the correlation between whether they selected that choice or didn't select that choice, and the total score on the test. The RPBI for the correct choice, that's what we refer to as the item discrimination. For the wrong choices, we'll call those the distractor discrimination. So just like with item difficulty, we'll have a discrimination for each alternative. We will have an RPBI anyway for each alternative in a multiple choice item. Because they are correlations, they will range from -1 to +1. And positive values indicate that the students who are picking that particular choice tended to be the ones who had high scores overall, and the ones who are not selecting that choice tended to have lower scores overall. To the extent that that pattern holds, you will have a choice that has a positive RPBI. Obviously, this is what we want for the right answer. We want the people who pick that right answer to be the ones who, generally speaking, are your high scorers, and the ones who do not get the right answer for an item are the ones who have lower scores overall. We want that exact opposite pattern for each of the wrong answers, for the distractors. We would like a negative RPBI. So that tells you that the people who picked that particular wrong answer are the ones who scored low on the test, and the ones who did not pick that answer tended to score higher. Remember, we want the high scorers picking the right answer, not the wrong answer. So we look for the distractor, each of the distractors to have a negative RPBI. It's also possible for the RPBI to be around 0. And an RPBI of 0 basically means you have no information about how well students scored based on knowing if they selected that choice or not. So the people who picked this particular alternative did just as well as the people who didn't. That would be an RPBI of 0. So in this particular context, we hope never to see RPBIs of 0. We will see them occasionally on items, but we're certainly not looking for RPBIs near 0. A second measure of item discrimination is usually just called the Discrimination Index, or D. The Discrimination Index is computed different ways on different item analysis output within the ExamSoft software, and in fact this is sort of the classic way of, and the most common way to compute this index, is to take a look at the students who are in the top 27% based on total score, so the highest achieving students, and then also the lowest achieving 27%. So create these two groups, get rid of the 46% of the students who are in the middle, just look at the two tails, and take a look at the proportion correct within each of those two groups. So how do your top students do on this item? How do your weakest students do on this item? And then just take the difference between those two. And so that's often used as a measure of item discrimination as well. So this is a sample of the ExamSoft item analysis, the way it's presented. And we can see a lot of the sorts of statistics that we were just talking about present here in the ExamSoft output. So Item difficulty actually appears in two different places. On the left-hand side, you see it says difficulty 0.63, but also the percentage of people who selected the correct choice, and we can see that A is the correct choice here because it has that little asterisk next to it in the in that first row. So we know that's the right answer. Those two are the same thing. The 63.46, if you just divide that by 100, so that you express it on a proportion scale instead of a percentage scale, it will always be the same as the difficulty. We can also see here the discrimination index, 0.56. What we get here, oops, here we go. Oh, I'm trying to do something that's not working here. I don't know, maybe so. Okay, let me, whoops. All right, I'm trying to do something fancy with the, here we go. Okay, so correct responses, we see the upper and lower, and those are actually the percentages of students in the upper 27% who get the item right, and the percentage of students in the lower 27% who get the item right. If you take the difference between those two, 90.05 minus 33.89, that's where we get the 56%. So that's where the discrimination index comes from. We also see right here is the RPBI for the correct answer. That's what we refer to as the item discrimination. And underneath B, C, D, and E, we see the RPBI for each of the distractors, so the distractor discrimination. So we're often asked, what exactly are we looking for in an item? I mean, we know what the ranges are for these different statistics. We know, sort of generally speaking, what we're looking for, but what sort of criteria exist for item difficulty and item discrimination? What Sonia and I usually tell people is that for item difficulty, you want most of your items to have a difficulty between about 0.35 and 0.85. As I said, you can have occasional items that are outside that range, but recognize that if they do get too easy or too hard, they're likely not to discriminate very well. For the wrong answers, the distractors, we like to see that we've created alternatives that are viable, that students actually are selecting. And so generally speaking, we write the alternatives with the idea that at least 2% of the examinees will select each of those alternatives. If you have an alternative and you've written it, you've invested the time writing it, and nobody's picking it, then it's not doing anything for you. So we write them because we're trying to have them help the item become more discriminating, and if no one's picking them, then that's not happening. With respect to discrimination, usually for standardized exams, Sonia mentioned the reliability criteria. Again, it's common for standardized exams, especially high-stakes exams, to have a higher standard with respect to discrimination. So usually there, we like to see RPBIs of 0.3 or higher. And for classroom tests, 0.2 is usually what we tell people. Some folks will go down a little bit lower and accept RPBIs that are in the mid-0.1s maybe. But again, the more items that one has that have low discrimination, the less reliable the test will be. As far as distractors, you want your wrong answers to have negative RPBIs. If they are negative, that suggests that the students who are picking them are the ones who are not as high functioning, not as successful overall. That's exactly what you're looking for. The more negative, the better. And the larger the number of people who select that alternative, the more negative you want that distractor to be. So this is a very difficult thing to explain. You sort of need to see it in order to understand it. So if we put a little example down here, if you have a particular item that has a wrong answer with an RPBI of minus 0.05, say, well, it's negative, but it's not a very strong negative RPBI. If the percentage of people selecting that choice is small, 5%, 8%, something like that, then it's really not that big a deal. But if you have a very popular wrong answer, maybe a quarter of the students are selecting a wrong answer, and that same wrong answer has an RPBI which is negative but pretty close to 0, that's going to be a problem, because what that's going to do is it's going to limit the right answer's ability to have a high positive RPBI. We know that the right answer will only be highly discriminating if the wrong answers, sort of taken collectively, are highly negatively discriminating. And if you have a really common wrong answer and it's got a very weak discrimination, then that's not too likely to happen. Okay, so let's return here to the ExamSoft item analysis. This is it now for a different item. And I just want to talk about a couple of things maybe that we see and what that might suggest to us about how an item is working. So in this particular item here, the first thing that I notice is that we have 3 choices that are really not being selected by very many people. Only 1% of the students are selecting C, about 0.5% are selecting D, and about, only one student, hardly anybody is selecting E. So although we've invested the time and we've written a 5 alternative item, in effect, this is really a 2-choice item. And we just know that 2-choice items, often aren't as discriminating. In this particular case, it actually seems to be an item that's working pretty well overall. It has a nice, solid, positive RPBI, but it does have these 3 item alternatives that really aren't very attractive. Let's look at another one. Here we have an item, and we see for a wrong answer, so B is the correct answer in this case, but we notice that alternative A has a positive discrimination. We don't like to see wrong answers with positive discriminations, and we certainly don't like to see wrong answers with positive discriminations that are selected by 50% of the students, which is the case here. If I were looking at this, I'd say, boy, that's a really big problem. That's something that I probably need to address. So item analysis gives us all sorts of information. We can use that then to help us figure out how to revise items, because just because an item isn't working doesn't necessarily mean that it's a good candidate to be revised. If we revise items and we're not doing it based on data, then we're likely to find the next time we administer this item that it also doesn't work well. And so using item analysis, we can make data-driven decisions about which items we choose to revise, which items we choose not to revise, and then but maybe retire and try again, and which items we decide to retain and perhaps use on subsequent exams. The number 1 rule in thinking about using item analysis is that you remember that item writing is really hard. And if you find an item that works well, and when I say works well, I'm talking predominantly, I'm looking at that discrimination and saying that the discrimination is high and positive, and is in the 0.2s, is in the 0.3s, something like that, and its difficulty seems to be reasonable, given the nature of the population that you're testing. If you succeed on both those fronts, then it really doesn't matter what else is going on in the item unless there's something glaring. The little things like not enough people who selected a choice, you want to ignore all that. If you're successful getting a good discrimination and a reasonable difficulty, then you pat yourself on the back and move on to the next item, because there's really no sense at all in trying to improve items that are already working. However, if items aren't working really well, if you have an item and it doesn't have a sufficiently high discrimination index, then the next thing I would urge you to do is take a look at what is going on with that item. If you're talking about an item that has a negative discrimination or a low positive discrimination, so a discrimination that's near zero, even if it's a little bit positive, those are the items that you either want to revise. If it looks like an item that can be revised, I'll talk about that in just a minute. And if you can't, then you delete it, because that's an item that's actually dragging down your reliability, and it's not doing what you expect it to be doing. The next thing is that you take a look at how the distractors are working. I like to say that items live and die on the strength of their best distractor. And so if there isn't a good distractor out there, then you're very unlikely to get this item working well. So take a look at the distractors. If you see some distractors that have RPBIs that are positive, that means the better students are the ones who are selecting those choices. Or if it's negative, but barely negative, with a lot of people picking that particular choice, that becomes a really good candidate for you to revise. Think about revising that particular distractor. Also, take a look if you have some distractors that are selected by too few people, less than 1–2%, or if you get distractors that are taken by an awful lot of people, unless the discrimination is really, really strong and negative. Obviously, you wouldn't want to change that. But if you have it and it's just sort of a ho-hum discrimination, but a lot of people are picking it, then that becomes a really good candidate for you to revise as well. Again, I said this before, that an item lives and dies on the strength of its best distractor. If you don't have at least one distractor that is really working well, it's unlikely that you're going to find the item overall is working well. Change only the pieces of an item that cause problems. If you have data to suggest that a couple of the alternatives are doing just fine and the problem really is in only one alternative, that's really the only place that you should be looking to make changes. Sounds like you were successful elsewhere, and if this one alternative hadn't sort of interfered, then probably the item would have performed pretty well. So if we look at how this works in practice, let's return to the ExamSoft item analysis. And we might look, we say, okay, here's an item that has an RPBI of 0.18, and Sonia and I sort of made up this particular analysis. It looks like we haven't indicated, but A is the right answer here. Oh, correct answer, A. There we go. Okay, Sonia's pointing it out to me. So A is the right answer. And it has an RPBI of 0.18, which is a little low. It's certainly lower than the 0.2, 0.3 criteria that that we like to see. We see that about 35–36% of the students selected this choice. So it's also a little bit on the hard side. And the odds are, if I could do something to make it a little bit easier, that I'd probably also make it a little bit more discriminating. When I look out here at alternative D, and I notice this has a positive discrimination. So that's something I really don't like at all. So that means that the good students are picking D too frequently. I also noticed that alternative C has a -0.07. So it's nice that it's negative, but it's not a really big number. It's still pretty close to zero. And 30.86% of the students selected that. That's kind of a lot of students. And taking with that many students who are selecting it, I would expect for it to have an RPBI stronger than minus 0.07. So that bothers me a little bit, but I'm really heartened to see what's going on in Alternative B. Alternative B, it was selected by 18.5% of the students. It has a nice, solid discrimination here of minus 0.21. So B is really an anchor for this item. I can sort of anchor this item to B and think about changing C and D. D definitely needs to be revised, but I figure C, I might as well revise that as well if I can come up with something that I think is plausible. And when I say plausible, I mean that the students might actually select it, even though it is unambiguously incorrect. But absolutely, you would not want to change B here because that's really what what's contributing to the whatever discrimination this item is already doing. So, item analysis is something it takes a lot of practice. It just takes looking at a lot of these item analyses, revising items based on the item analysis, then revisiting afterwards, seeing how well the items performed, now that they've been retested, and really getting a feel for what sorts of changes you're making in items and how they're causing the item to improve down the road. So, I would urge you really to start taking a look at that if you haven't been, and focus in first on those items that have the lowest RPBIs. I mean, absolutely, you want to get rid of any items that have negative RPBIs, and then start to impose some sort of a standard. As I said, we use an RPBI standard of 0.3. We've talked about 0.2. That may be unrealistic for you at first. Maybe you want to start by using 0 and just getting rid of the negative ones, and then as your test becomes more reliable, you'll reevaluate how your items are doing, and then you can maybe think about raising the RPBI standard to 0.1, and then maybe after another iteration you can think about raising it to 0.15 or 0.2. It may be something that you need to sort of do over time, but by taking this sort of a systematic approach both to test design and also to item revision, I'm confident that you can develop assessments that are highly reliable for classroom purposes. And I think that is the end of the formal presentation that we have here. But I believe that Stephanie has been collecting some questions.
Yep, thank you so much. That was great. I'm just going to go ahead and just reiterate, if you have any questions for Dr. Wallach or Dr. Siddiqui, please click on the questions area of the Go to Webinar box on the side of your screen. There will be a box for you to type the question into, and then we'll have them answer the questions as they come in. Okay, so the first question, I believe, was based off of the beginning of your presentation. It is, how do we determine, quote, validity evidence, end quote?
How do we determine validity evidence? Is that the question?
Yes, that's the question.
Yeah, so it's a very difficult, I mean, validity is a really complicated area, and the approaches that are used by, and there's been a lot of writing on this exact question. Validity is basically an argument. So one needs to, it's not a number, there's no quantitative standard for validity. It is an argument that you can make that says this test is doing what it's supposed to be doing. There are a number of analytic approaches that are used by standardized testing companies to make sure that the models that they're using are appropriate, to make sure that the items are performing fairly and equitably across different types of examinees. I mean, there's a lot of stuff that people that can be done, but that's probably not realistic for classroom purposes. For classroom purposes, really, I think it's a two-step argument. The first step is to show that your test is reliable. We know that reliability is a precursor to validity. If you can demonstrate that your test is reliable, that means that there's the potential for it to also produce scores that are valid. If it's not reliable, then there's rather limited potential for it to produce scores that are valid. So making sure that it's reliable is step one. And then the second step is to demonstrate that the test is measuring the content that is most directly relevant to your class. And that's where the blueprint comes in really, really handy. This is something that you can say, look, I know my test is measuring, it is intended to measure these particular content areas. It's not overly narrow. It's not weighted too heavily towards a particular content area, but it's appropriately balanced. It's appropriately broad and focused. And that's really the best approach for classroom testing, I think. I don't know, Sonia, if you've got anything to add to that.
I think that was an excellent answer.
I'm sorry, Sonia, we couldn't hear you.
Oh, no, I said that I thought that was an excellent answer.
Okay, great. The next question was somebody would like clarification on the term when you guys were talking about multiple midterms. Could you explain what you mean by multiple midterms?
Midterm maybe is not the correct term to use there, but administering multiple exams throughout the semester that your course is being offered, not having the final exam weighed or have the final grade weighed just on one exam. Having more than one additional assessments, all of that is going to help to improve the reliability of that final grade.
Great, thank you. Next question we have is, are the top 27/bottom 27% redetermined with each exam, or is this predetermined for all of the exams?
No, it's determined for each exam. Yeah, so it's always
great.
the top 20. I'm sorry?
I'm sorry, go right ahead.
No, just to reiterate, it is exam standards, so the top 27% based on that particular exam's total score, and it might be slightly different students who were in the top 27% for a subsequent exam, for example.
Okay. Next question is, how does reliability for the entire test when a single test may be investigating multiple areas?
So if I'm understanding, so we don't always write tests to measure one and only one thing, right? Sometimes we write tests that measure different areas. If we're really in a situation where we don't necessarily expect the items to be similar, they're not all measuring a common construct, then you probably wouldn't want to look at something like a KR20, because KR20 is at least not over the entire instrument. Perhaps in that sort of a situation, you would be better served by making subscores, subscores that are sort of focused and all, so that each subscore measures one and only one thing. And then I think it makes sense to look at the KR20 within the subscore. But if you're really interested in reliability, true reliability of something that's measuring different types of things, really the only way that you do that, and it's not something covered by the ExamSoft diagnostics, would be like a pre-post administration. So you test, retest students on something, but you probably in that situation would not do a KR20.
Great. Next question is, do you have a plugin for ExamSoft that can be used in Blackboard testing?
You know, I think that's a question that's going to have to be sent to ExamSoft. So I don't know. We don't actually work for ExamSoft, and so I'm not telling unless you know, Sonia. But yeah, I guess I'm not exactly sure what plugins and capabilities they may have.
Sure, absolutely, and I can actually answer that for you guys. ExamSoft does have a building block, and we do correspond with Blackboard as well. So yes, there are the capabilities for ExamSoft to work with Blackboard on both a program and an institutional level if necessary.
Excellent.
The next question is, we have an integrated curriculum where faculty from different departments contribute items to the same exam. How will this affect our interpretation of biserial and KR20? Is it valid to calculate an average of the biserial cross examinations for the same item revision when the context of administration may vary greatly?
So I'm not sure if I fully understood the question, but one thing is to think back to what Jim was just saying about using KR20 in the context of if you potentially have multiple subscores. It's the case that individuals from various disciplines are writing different test items, and you really have something that looks like subscores. Again, you don't want to be looking at the KR20 for the overall test value. But I'm not sure if I fully understood that question or not. Jim, do you have any?
No, I think I'm sort of with you.
Okay. That question was from Glenn Davis. Glenn, if you have a follow-up question, or if I didn't ask the question correctly, please type up a follow-up question into the chat box. And we can address that in a moment. Next question is, in nursing, there are some questions you expect all students to answer correctly due to safety. Therefore, do you identify those questions prior to doing the item so you understand and expect the item discrimination to be 100%?
Yeah, I think that's a really good point, and it's something that we probably should have mentioned. I should have mentioned in talking about item analysis that you know, the procedures that we were talking about, thinking about reliability, thinking about the item analysis approach to maximizing reliability is premised on an assumption that you're developing a norm reference test, where the idea is that you're trying to create variance among students. And the nursing example is a great example of what we might call a criterion reference test. So there are certain things that we, not only do we expect students to know them, we have to check to make sure that they know them. And absolutely, we know that in a lot of professional programs there will be items like that, and it's important to have them. I would suggest building them into the blueprint. Recognize that they're not going to help your reliability. They're just not. But you know, you don't discard them. You don't evaluate them basically on the same criteria as you evaluate the items that are intended to provide more of a norm referenced interpretation. So yes, it's absolutely okay to have them. It's okay for there to be items there that everybody or almost everybody gets right, simply because you need to be certain that you're not letting people advance through your program who don't know the absolute fundamental stuff. That's fine, and just proceed with the understanding that they're not going to help your reliability, and the reliability of your test is going to have to be built off of the other items that you choose to ask.
Great, thank you. Another question, how many students do you need in a cohort to have a reliable measure of the KR20?
I don't know that there's an actual, magic number. So, I mean, usually, by the time you get 100 some odd students, the variability around the KR20 starts to become pretty small. So, maybe that's the number. But, it's something that I know, it's something that we often don't have any control over, of course, right? And so if you teach a class that has only 30 students, I think what it suggests is, okay, maybe you take it with a little bit of a grain of salt, and you start to take more of a longitudinal perspective and say, all right, I'm not going to make any, I'm going to make, I'm only going to address maybe the really bad items, and I'm not going to interpret a low reliability until I see it again, right? I want to administer this test or many of the items on it a second time, and then if I'm seeing the same general pattern, then I'm a little bit more apt to believe it. So yeah, absolutely, these things have standard errors. They have variability associated with them, and it is sample size dependent. So, I think by the time your samples get to be around 100, you're in pretty good shape, and under that, proceed with a little bit more caution.
Okay, great. I'm loving all these questions. We've got a lot more questions. So if you're able to stay a little bit longer, we can go up to another probably 20 minutes or so. So I'm just going to keep reading the questions, and if anybody needs to drop off, that's fine. But I'm going to keep on going with the questions, even though we've gone past our time.
Okay.
Next question is, yesterday I gave an exam to 2 sections of the same course, but graded them separately. Both had 21 to 22 students. KR20 was 0.80 on one and 0.18 on the other. Any insight you could share on that?
Well, so interesting. We just talked a little bit about the volatility of KR20, and you're talking about samples of 20. It's obviously going to be a little bit more variable. There are other things, of course, that go into KR20, and some of this would be like the homogeneity of the group. It would be interesting to know whether, do you really think that the students in one class maybe are either better than they are in another, or in particular, are they more variable? And so you start talking about different sections, and we know that it's not always random when people take courses. So if one of these classes is at 8 in the morning, it's a certain type of student who who takes that. Maybe it's a better student, and so maybe that tends to be a class that has all A and B students, and your other class has A, B, C, and D students, and maybe some F students in it. The more variance there is in your population, or you're in that section, the more reliable your test is likely to look. It's sort of an artifact, but it's the reality of the situation.
That would have been, the thing to keep in mind is that you're dealing with smaller sample sizes, so that first is going to potentially affect the KR20 values. And then, like Jim said, if for whatever reason one of your section students are really heterogeneous based on their ability level or their comfort with the content being taught in the class, then that's also going to result in having KR20 values that are lower.
It would be interesting, if you haven't done this, to pool the data in the 2 sections and run a KR20 on the entire group, because that's probably the I mean, that's probably an appropriate thing to do, and it's probably going to give you your best estimates and most stable estimates, not just of KR20, but also of the p-values, the item difficulties, and the discrimination, the RPBIs.
Okay, great. Next question is biserial also sensitive to multiple domains like KR20?
I'm not certain I'm understanding the question. The KR20, what?
Subscores, I think, basically. Is it going to be sensitive to if your test, essentially you should have subscores on it, whereas like KR20 is going to be susceptible. It's going to be lower if you're pooling all of those items together, but they should be broken out into individual subscores. The one thing to remember with the point biserial correlation is it is the correlation between a total test score and that individual item, which could come into play there, similar to with KR as it would with KR20.
Right. Yeah. The limitations in KR20 extend to RPBI, and so if you are dealing with a test that's not homogeneous with respect to content, so it's maybe measuring different constructs, then yeah, that's going to suppress the values of your RPBIs. It's also going to suppress the value of your KR20.
Okay, great. Next question is, how do select all that apply or multiple answer questions affect your item analysis?
Well, I don't think it affects the item analysis per se. Select all that apply. I'm sorry. I sort of misheard. So I mean, you can. You could set up the item analysis to sort of treat each answer category as as its own. So as its own category, or each answer combination as its own category. If you wanted to separately look at the people who said A and B, different from the people who said A and C, separate from the people who said only C, right? You could. I don't think it's part of ExamSoft's standard IA package, but if you exported the data, you could potentially do that. You could also look at the item categories, just saying, look, was A among their choice? Did they select some choice that used A? Did they select some choice that used B? Did they select some choice that used C? And even though those will sum to a number greater than your total, because some people will sort of fall in multiple categories, you can still run the same statistics, and you're still sort of looking for the same general trend. But I think my understanding is that none of the ExamSoft analysis really allows you to do that. And I think there are some questions also about whether or not those types of items, generally speaking anyway, are best practice. I think there might be select instances where it's a reasonable thing to do, but generally speaking, those types of constructions are probably things we'd like to avoid. They often confuse students. It's very difficult to figure out what students really know and don't know from those, unless perhaps they get it. If they get it exactly right, then it's fine. But of course, those items are really difficult, and they don't provide much information about individuals with partial information.
Great. And as a follow-up question, there's also how is KR20 affected by differentially weighted items?
I mean, there's no formulaic way that I know, but it's obviously going to be more heavily influenced by the more heavily weighted items. Yeah. So if you weigh if the items that are more heavily weighted happen to be ones that are pretty highly reliable, then you're probably going to be okay. And if you're putting more emphasis on items that are less reliable, then your KR20 is going to be lower.
Okay, last question is why upper 27% and bottom 27%? Why not quartiles instead?
Yeah, that's a darn good question, isn't it? Yeah, you know, I don't know exactly what the history is. I do know that the discrimination index, that upper minus lower, has largely fallen out of disfavor. It was something that appeared in all of the educational measurement books through the 50s and 60s, and before we had good computers, and before computing something like an RPBI was easy. You know, then that used to be done because it was easy to do. I suspect the upper and lower 27% might think about a bell curve, and yeah, what coefficient might cut that off. I know one standard deviation to 68% are in the middle. That's 16% above one standard deviation. So maybe it's half a standard deviation. I'm not quite sure what it is. But and you know, you'll see in different item analysis packages that's sort of treated differently. Some will look at the upper third versus the lower third, with the middle third dropping out entirely. Some will do it as quartiles, and that way your discrimination index is essentially your interquartile range, which I actually find kind of appealing. But I don't know. It's a good question. There's not going to be an appreciable difference between upper and lower 27% or thinking of it as the interquartile range.
Okay, thank you so much. That is all the questions. Phew, got through them all. I want to thank everybody for being here today. Thank you so much to Dr. Wallach and Dr. Sidibe for taking time to give the presentation. Just as a reminder to everybody who's still on the line, you will receive an email tomorrow that will have both a link to the recording of this webinar as well as a copy of the presentation deck. That way you will have it for your reference and to share with whomever you'd like. Thank you so much for being here, and everybody enjoy your afternoon.